All right, well, for the purposes of the video, we are Butler University, Chemistry in the Community. I'm Shelby Skaggs. Also here is Amanda, Carly, and Joey. We'll be starting our presentation with Oobleck.
Oobleck is a fun mixture made by combining roughly 2 parts cornstarch to 1 part water. When mixed, the starch particles become suspended in the water, meaning they float around without dissolving. Left alone, the starch particles float freely past one another and the oobleck behaves like a liquid. When force is applied, the starch particles lock together, causing the oobleck to become solid. This type of behavior makes oobleck a non-Newtonian fluid. Non-Newtonian fluids change viscosity or thickness with changes in force or temperature. In the case of oobleck, an increase in force causes an increase in thickness, a process known as shear thickening.
As you can see here, here's an example of what the texture of your oobleck should look like. It should have that drippy consistency when you move the direction of your container around. Otherwise, when your container is still, it should look like a solid and not drip at all.
Here is an example of applying force to the oobleck where it becomes solid like a rock. And then when you stop applying force, it drips down into a liquid.
Here we apply a hammer to the oobleck, once again showing how it behaves like a solid when force is applied.
What other fun things can you think to do with oobleck? Make some at home and play with it yourself.
Next, we have our slime video.
So right now we have borax in our beaker, and now we are adding our color dye. Now we are going to add our water, and we're going to mix it up as best as we can until it looks like everything is dissolved. You can already see that it's changing color because we used warm water, which turns the red dye color to the yellow color. Next, we're going to add our glue, nice and sticky. Then we're going to mix it all again. And you can see how it's already starting to stick together a little bit. Now we're going to put it inside of a bag so we can mix it a little bit more with our hands. When it's in the bag, we're just going to kind of grab it and mash it around just to mix it up a little bit more. Now before we take it out, we're going to show how the color changing dye works in different temperatures of water. Since it's already warm, we're going to put it in the cold ice and it should turn back to red. Now if we put it back in the warm water, it should turn back to yellow. The slime sticks to our gloves, so to show you how slimy it is, we're going to take them off. If you pull the slime really slow, it will stretch, but if you pull it really fast, it will just break off. And that's how you make slime.
Hey everyone, next up we have the at-home red cabbage pH indicator lab. Can everyone see this?
Yeah, we can see it.
Awesome. So first off, we're going to take our red cabbage and we're just going to tear it up and throw it in the blender. We're going to be using the red cabbage juice as a pH indicator for our different solutions. So once that is fully blended up, we will be filtering it through coffee paper into just a beaker just to obtain just pure extract. And once we have enough of our red cabbage juice, we're gonna take multiple solutions, including we used sugar, Windex, Sprite, vinegar, lemon juice, and hand sanitizer, all of which is pretty easily accessible, and a lot of them are actually found around your house. So we took these solutions, diluted it with some water, and then once we had all our solutions prepared, we poured red cabbage juice to indicate the color ranging on the pH scale. So as you can see, the red cabbage makes the solution change immediate color, and this color is going to be used to indicate what level of the pH, whether it's acidic or basic. So when referencing a pH scale, we were able to arrange the different solutions on their acidity, with a darker red being the most acidic and purple being the most basic. And here's just all our solutions in order their pH to acidity. Awesome. Thank you.
So finally, we